Hello everyone, welcome back to my channel. My name is Soumya. In today's QwikLabs series, we'll be doing this lab managing deployments using Kubernetes Engine. So let's start the lab. So as part of this lab, we have 5 tasks. The first task is creating a deployment object. Next, we'll be creating a deployment. Third will be rolling update. And in the fourth task, we'll be creating the Canary deployments. And finally, we'll be performing the blue-green deployment. So once you log into the Google Cloud Console, you need to activate the Cloud Shell. So click on Activate Cloud Shell. So you can maximize this window. So here to activate it, you can execute gcloud auth list. So configure your account. We have completed the prerequisite. We have activated the Cloud Shell by executing this command gcloud auth list. We'll be setting the Google Cloud Zone by executing this command. So in this specific zone, we'll be performing all these tasks. So let's copy this and execute here. So now our zone is set to US West. So to perform this deployment task, we first need to get the sample code for this specific lab. So you can copy this code. So let's execute this command and copy the code. Here I got a wrong number of arguments for cp command because I didn't specify where to copy that. And here I have given a dot. This represents that this specific code will be copied to this current working directory. The command gsutil-m cp-r. So this command is used to recursively copy files and directories from a Google Cloud Storage bucket to the current directory. So a gsutil is the command line tool for interacting with the Google Cloud Storage, and -m it represents a multi-threading. So it allows multiple objects to be transferred concurrently. And cp is the command which we use to copy files and objects. -r indicates that the copy operation should be performed recursively. So it recursively copies all files and subdirectories within the specified source directory. And the next is gs colon followed with this spls. So this specifies the source location from where the files and directories will be copied. So in this case, it's a Google Cloud Storage bucket. So spls is the storage bucket and the directory is the GCP 053. And subdirectory, it is orchestrate -with -Kubernetes. And dot represents the current directory. And it specifies the destination location where the files and directories will be copied. So therefore, running this command will copy all files and directories from the specified Google storage bucket and directory to the current directory on the local machine. So in our case, our current directory is our local home space. In our case, all the files and directories gets copied to our local working area. So let's execute this. Now the operation is complete. So we need to cd to that folder where we have copied our code. So this is a directory which contains the sample code. So let's cd to that. By executing ls, you can see view the contents in this directory. Next, we need to create a cluster with 3 nodes. So let's copy these and execute here. gcloud container clusters create bootcamp. So this creates a Kubernetes cluster name bootcamp. You can replace the bootcamp with your desired cluster name. Next is -machine -type e2 -small. So this specifies the machine type for the cluster nodes. Here we are using e2 -small. And if you want to have a different machine type, you can set it accordingly. -num -nodes 3. So this represents the number of nodes in the cluster to 3. So you can also adjust this value as per your requirement. -scope, this HTTPS, this URL, this specifies the IAM. So IAM is nothing but identity and access management. So this specifies the IAM scope for your cluster. So as you can see here, project hosting and storage, we are giving read-write access. You can also modify the scopes based on the services you want to enable for your cluster. By running this command, we'll be creating a Kubernetes cluster with the specified settings in GCP. So let's execute this command. So this command will create a cluster with 3 nodes, and it also sets the scope which we have defined here. So here you can see the creating cluster bootcamp in US West 4. So we have set the zone to US West 4. That's why our cluster is getting created in this specific zone. Now the cluster is created. So it's created at this location, And to inspect the contents of the cluster, you can click on this URL. So that URL will take you to the Kubernetes engine page. So let's go to clusters view. So here you can see bootcamp. This is the cluster name which we had given, and the location we had given it as US East. Number of nodes, it is having 3. So it is having all the specification which we have mentioned. So let's click on this bootcamp. So this shows the cluster details here, where it has been created and what are the configurations we have applied to this cluster. You can view the details of this cluster in this page. And let's click on nodes. So we had created 3 nodes here. So this is a node pool. It has created a default pool containing 3 nodes inside that. So under node section, we have 3 nodes created, and the status of all these 3 nodes are in ready state. Okay, now the cluster creation process is complete. So let's move on. Using the explain command, you can check the details about this deployments. So let's copy this and execute here. So let's execute this command. So by executing kubectl explain deployment command, you can get detailed information and documentation about the deployment resource in the Kubernetes. So using this command, you can see what all the different attributes you can use along with this deployment resource. Like it will explain, it will provide a detailed explanation about all these fields like API version, kind, metadata, spec, status. So everything, it will provide a detailed description about these fields. Okay, let's move ahead. So you can also use the -hyphen recursive option here. And you can also use the explain deployment with the metadata name. And now we have completed the task 1. Let's move on to task 2. So here we will be updating the deployments. Here we will be updating the hot.yaml file. So in this hot.yaml file, we need to change the image. So change the image in the container section of the deployment to the following. Let's vi into that hot.yaml. And so using vi, you can edit the configuration file. So under container section, image, we need to change it. So we have to update this specific field. Under spec section, the containers, here, let's update this. Now it is 2. You have to click on hi, so it will take you to the insert page. So we can edit it, change it to 1. To save this, you need to press escape button, then colon WQ. So this will save your configuration file. Next, you need to enter. Now it is changed. Okay, once that is done, so you can cat that file, run cat deployments auth. So here you can see, so this is the one which I have changed. I've changed only this line. I've changed from 2.0.0 version to 1.0.0. So once this is done, we need to execute this command kubectl create -f deployments. So this is the configuration file. So this command kubectl create -f deployments /auth.yaml. So it is used to create the Kubernetes resources as per the configuration which has been defined in the YAML file. So let's understand this auth.yaml file a bit. So this is a YAML file which describes a Kubernetes deployment resource. So let's take a look at each of the contents in this file. The first one is the API version. Here we will be specifying the API version of the Kubernetes resource. So here it is using apps/v1 version. And the kind is the deployment. So this defines the type of Kubernetes resource being created, which is the deployment in this case. Next is the metadata. So this contains metadata about the deployment, such as its name. Next is the spec. This specifies the desired state of the deployment. Here we have set the replicas to 1. So this will set the desired number of replicas, which is nothing but pods, for this deployment to 1. Next is the selector. So under selector, we specify the labels, which is used to select which pods belong to this deployment. And this match labels defines the labels to match against pod labels. Next is the template. So under template, we describe the pod template used for creating the pods. Under this template, there is another metadata. This contains metadata specific to the pod template. Next is the label. Here label defines labels for the pods created from this template. Next is a spec. This specifies the pod specification including container details. Under containers, you can describe the containers running in the pod. Like you can set the name of the container under name, and then you can specify the Docker image to use for the container. Under ports, you can define the ports to expose in the container. Under resources, you can set the resource limits for the container like CPU and memory. And liveness prop is nothing but it configures the L check to determine if the container is running properly or not. Finally, it's a readiness prop which configures L check to determine if the container is ready to receive traffic. So this YAML file defines a deployment resource. So this specific YAML file will create a single replica of a pod, and this pod runs on a container based on this image, whatever image we have specified in the YAML file, and it exposes the ports, and it sets the resource limits, configures liveness and readiness props, and use labels for identification and pod selection within the deployment. So let's execute this command kubectl create -f deployments /auth.yaml. So this will create a deployment object. So let's execute this. So now it's created, and we can verify that using kubectl get deployments. So let's copy that command and execute here. Okay, kubectl get deployments. It will list the available deployments. So we have created only one deployment by the name auth, and it is showing the details here. The status is ready. Once the deployment is created, it will create a replica set. So let's verify that. Copy this command and execute here kubectl get replica sets. So what this command does is it will retrieve the information about the replica sets in a Kubernetes cluster. So when you run this command, it will query the cluster and return the list of replica sets. Here kubectl is a command line interface tool for interacting with the Kubernetes cluster, and get here specifies that you want to retrieve information about a specific resource. And replica sets are nothing but a resource type you want to retrieve information about. Executing kubectl get replica set will fetch the details about the replica set which are available in the cluster. So this command will communicate with the Kubernetes API server, and it retrieves all the information specific to this replica set. So when you execute this kubectl get replica set, will show the name of the replica set and the desired number of replicas which are specified in this replica set, and the current available number of replicas that are running under available. And ready state is nothing but the number of replicas that are ready and available to serve the request. And here age represents the age of the replica set, which indicates how long it has been running. So here under ninth step, we can view the pods that were created as part of our deployment. So we have created only one single pod. So let's copy this command kubectl get pods and execute here. So it will show only one pod here. So yeah, this is the pod and it is in a running status. Next, we need to create a service for this deployment. So let's copy this command kubectl create -f services /auth.yaml and execute here. The service is created now. Now we will do the same thing to deploy our Arelo application. So we'll be creating this. So this is a lo.yaml file. So we'll be creating this deployment and we'll be exposing this by creating a service to that. Okay, so let's do it at once. So here you can see the deployment allow is created and it has been exposed. Next, we will be doing the same to expose a front-end deployment. So let's copy one by one kubectl create. So this command will create a Kubernetes secret resource name tls-search using the contents of the files located in the tls directory. So here create secret generic. This will create a generic secret resource, and tls-search is the name of the secret. So it will create a secret by the name tls-search, and from file tls/ this specifies a source directory from which the secret will be created. So in this case, it references the tls/ directory. Let's copy this first command and we'll execute this. It's created. Let's create a config map for the front end. So this command will create a config map resource named nginx-frontend-conf using the contents of the file nginx/frontend.conf. So the here create config map creates a config map resource, and nginx-frontend-conf specifies the name of the config map, and here -from-file is equal to nginx/frontend.conf. So this specifies the source file from which the config map will be created. Now let's execute the second command. Now this is also created. Now finally we will be creating a front-end deployment. Let's execute this command. It's created. Now finally we will expose this. We will create a service to this front-end deployment. So now that is also done. So we will execute this command kubectl get services frontend. Executing this will provide us the external IP address. Now we have the external IP address here. So next we need to call this external IP address. Let's copy this. And here we need to provide this external IP address. Okay, enter. So now we are getting the message hello. So we are getting the hello response back. So you can also use this method to call it as a one-liner. Once that is done, you can click on check my progress and the task should be completed. So now we have created our deployment. Let's scale our replica set here. So using kubectl explain deployment spec replicas, we can see the explanation of this, like how to use this. You can execute that. When you execute this kubectl explain deployment spec replicas command, it will show the detailed explanation about this. Using kubectl scale command, you can update the replica set. Copy this command and execute here. So now this replica set is scaled. Once the deployment is updated, Kubernetes will automatically update the replica set and it will start new pods. Now since we have set it to replica set as 5, so it will create 4 more pods here. So we can verify it by executing this command kubectl get pods. So now it is showing it as 5. So since we have updated our replica set to 5, it has created additional 4 pods. Let's scale back the application to 3. So let's copy this command and execute here. Now it should be scaled to 3. Let's copy this and check the number of pods available here now. Kubectl get pods. Now it should show it as 3. So let's perform task 3 rolling update. So here rolling update refers to a strategy where we update or modify the resources in a controlled and a gradual manner. So this minimizes the downtime and ensures high availability of the application or the service. So in Kubernetes terms, this rolling update is a feature which will allow you to update a deployments such as pods by gradually replacing the old instances with the new ones. This rolling update follows these steps. Kubernetes will create a new instance are nothing but pods with the updated version of the application. Then the new instances are gradually added to the pool of available instances. Later, the old instances are gradually removed from the pool. This process continues until all instances have been replaced with a new version. And this rolling update strategy ensures that the application remains available throughout the update process. So this will minimize the impact on user traffic. So this rolling update allows for a smooth transition from the old version to the new version with minimal disruptions or the downtime. So by using rolling updates, you can perform updates to your application or services in a controlled manner, ensuring that your users experience minimal interruptions and your system remains highly available. Let's perform this rolling update. So we can perform this rolling update by editing our deployment. Let's edit our deployment. Let's copy this command. Let's execute this command. So here we'll make a minor change like updating the container version. We will update this containers image. So here we'll change this to. So we have made the changes. So let's save this. We have updated this. Now we have updated our deployment. Once we save this, the updated deployment will be saved to the cluster and Kubernetes will begin the rolling updates. So let's check that. We will execute get replica set. Let's copy this. When we execute this command, you can see 2 deployments by the name hello, right? So the another one got created because we have updated our deployment. So the Kubernetes has identified this and it has begun with a rolling update. So we can check the rollout history by executing this command kubectl rollout history and the deployment name. And a revision you can find there are 2 revisions available here. Now let's pause this rolling update. So we don't want this rollout to happen. Let's pause this. So we can execute this command kubectl rollout pause deployment. So now the rolling update is paused. Next, let's check the status of this rollout. We have paused the rollout, so it is showing the status as this. If you want to verify this on the pods rightly, you can execute this command. Let me execute this command. Here you can see it's updated. to the newer version. We have changed from 1 to 2, so it has updated it on the pods. And if you want to resume the rolling update, you can pass the resume command here. So let's copy this and let's execute it here. So this will resume the rollout. Again, you can check the status of this rollout by executing the same command, rollout status deployment. And so it will show the status. And if you want to roll back an update, say for example, like there was a bug in your new version and you want to roll back to the previous version. So you can do so by executing the command kubectl rollout undo deployment. So let's copy this and execute this command. So this command will undo the rollout, which means it will roll back to the previous version. So let's check the history of this. Now you can find the revision 3. Can verify this on the pods by executing this command kubectl get pods. So here you can see it has rolled back to the previous version. Now let's move ahead with the Canary deployments. Let's take a look at Canary deployment. Canary deployment involves gradually rolling out the new version to a small subset of users or systems known as the Canary group, while leaving the majority of the users on the previous stable version. So if you want to test a new deployment in production with a subset of your users, you can use a Canary deployment. So this Canary deployment will allow you to release a change to a small subset of your users to mitigate risk associated with the new releases. So the main purpose of Canary deployment is to validate the new version stability and performance in a real world environment before fully releasing it to all the users. Let me explain how the Canary deployment works. A small portion of user traffic or a specific group of systems is selected to receive the new version. So this could be, say for example, 5% of users or a specific geographic region. Next, the new version is deployed to the Canary group and their interactions with the application are closely monitored and analyzed. This includes measuring performance, monitoring the error rates, and gathering user feedback. And if this Canary group shows positive results, this indicates that the new version is performing well and it meets the expectations. Later, this deployment will be gradually expanded to the larger audience. Once this new version is performing well, the percentage of the users are increased gradually and the new version is rolled out. If there is any issues or negative impacts are detected during the Canary deployment, the rollout can be stopped or rolled back to the previous version to minimize the impact on users. So by using this Canary deployment, organizations can mitigate the risk of deploying faulty or problematic updates to all the users at once. So it allows you to carefully monitor and validate the new version's behavior in a controlled manner. So this deployment consists of a separate deployment with a new version and the service that targets both your normal stable deployment as well as your Canary deployment. Let's cat this canary.yaml file. So we have defined the configuration, Canary deployment configuration here. So let's create this Canary deployment. We will copy this command, execute it. So now the Canary deployment is created. So this Canary deployment should create two deployments, hello and hello-canary. So let's verify it by executing the command kubectl get deployments. We have two deployments, hello-canary. A hello is a prod deployment, hello-canary is a canary deployment. So it will match the ports in both of it and serve the request accordingly. So let's verify this by executing this command. You can execute this command multiple times to see how the requests are getting served. Here you can see version 2.0.0 is served. Execute the command again, it is serving the version 1.0.0. Like both of versions it's serving. This is how the Canary deployment works. So you can check your progress, it should be done. Now let's move ahead with the blue-green deployments. Blue-green deployment is aimed to minimize the downtime and reduce risk during the deployment process. So in blue-green deployment, two identical environments are created, referred to as blue and green environments, and switching traffic between them. So this is how it works. Initially, the blue environment is the live production environment where users access the application or the service. When the new version of the application is ready for deployment, the green environment is set up to mirror the blue environment. So the green environment includes the updated version of the application. Traffic is then directed to the green environment. allowing a subset of users or a specific group of systems to access the new version. So these ensures that any issues or bugs in the new version are isolated and impact only a limited audience. Meanwhile, the blue environment continues to serve the majority of the users who are still on the stable version. The green environment is thoroughly tested and monitored to ensure its stability and performance. If any issues are detected, the traffic can be easily switched back to the blue environment. So once the green environment is deemed stable and successful, traffic is completely routed to the green environment, making it the new live production environment. In Kubernetes, you can create two separate deployments, one for the old blue version and one for the new green version. So you can use your existing yellow deployment for the blue version. The deployments will be accessed via service which will act as a router. So once the new green version is up and running, you will switch over to using that version by updating the service. One of the key benefit of blue-green deployment is that here we can seamlessly roll back if any problem arises during the deployment. If issues are encountered in the green environment, we can revert back to the blue environment. You just have to switch the traffic. So this will ensure minimal downtime and it also reduce the impact on the users. But one of the major downside of blue-green deployment is that you need to have 2x of the resources in your cluster. So first we need to update the service. So let's copy this, execute it here. Now it's configured. Let's create a green deployment. Copy this command, execute it here. This will create a green deployment. Now it's created. So once a green deployment is created and started properly, we can verify the current version. Let's copy this and execute this command. Let's understand what this curl command does. So this command is used to retrieve the version information of a service name frontend, which is deployed in the Kubernetes. Here, curl is a command line tool used to make HTTP request. -ks. So these are the options which we pass to the curl command. Here -k is used to ignore any SSL certificate validation. So this will allow HTTP request without verifying its server certificate. And -s is used to silence the progress and error output. kubectl get svc command is used to dynamically fetch the external IP address of the front-end service and extract the IP address using the JSON path output format. Next, it will query the Kubernetes API to retrieve the service information for the front-end service. -o is equal to JSON path. So this option specifies the output format as JSON path. This will allow us to extract specific values from the JSON response. So here in this case, we are extracting the IP address of the service load balancer. So overall, this command is used to easily retrieve the version information of a deployed service by making an HTTP request to the service IP address obtained from the Kubernetes API. So here you can see it's serving version 1.0.0. Now let's update this service to point to the new version. So new version should be 2.0.0. So let's execute this command. Now again we will run that curl command. So now it will point to 2.0.0. So when we update this service, the green deployment will be used immediately. So if you want to roll back the blue-green deployment, you can just update the service to the old version. So let's copy this. We are just updating the blue deployment. Let's copy this and execute this, and now it's configured. Verify this by executing this curl command, which will be 1.0.0. So that's how we do the blue-green deployments. So that's it for today's lab. I hope you found this video helpful. Please like and subscribe to my channel and stay up to date with the latest videos. Thank you all for watching. See you in the next video.